Welcome to Direct Stars channel. Today we'll be looking at nanoparticles. I know you must have heard of nanotechnology or nanoscience. Okay, it's a study of particles that are of 10 to the power minus 9 meters in size, very small. And today we'll be looking at defining nanoparticles and explaining how their properties differs from the bulk materials. We'll describe the size of nanoparticles relative to those of the bulk materials. We'll also be looking at explaining the properties of nanoparticles, the advantages and disadvantages of nanoparticles, okay, and why we use them for certain things or certain products. Okay, so what are nanoparticles? Simply, they are very small particles between 1 to 100 nanometers. Okay, and what is the equivalent of your nanometer in meters? Is actually 10 to the power of minus 9. Okay, this is what 1 nanometer uh, is. Okay, if we're to show this mathematically, that will be 0.00000001 meters. Okay, what this means is they are so minute. Okay, so small. Okay, that is what this means. You can look at what 1 meter is and what 1 nanometer should be. Okay, it's so small. And this small size of it avail it the opportunity to have very large surface area to volume ratio. Okay, so this gives it a unique properties. Okay, so it makes them more reactive, more useful, okay, in various products. That means they contain only a few hundred atoms and are larger than atoms, okay? But actually they are smaller than the bulk materials, okay, that we studied the last time. Okay, so the uses of nano particles. Okay. Some examples we may come across will be your fullerenes, okay, which are nanoparticles made of carbon. Okay. So, we treated allotropes of carbon the last time, and we looked at diamond and graphite. So we have the fullerenes, Bucknell, and the others. So, but we'll be looking at the fullerenes as nanoparticles made of carbon. Okay, that is a very good example of nanoparticle. So, like I said, the higher the ratio of your surface area to the volume, the better, okay, in terms of reaction. And that is why nanoparticles act as better catalysts than the regular transition metals that we use as catalysts for reactions. Okay, so I will take that again. The reason why nanoparticles are better catalysts than the transition metals is due to their very high surface area, okay, that they possess, or high surface area to volume ratio that they possess. Uses of nanoparticles. Nanoparticles have had so many applications that have made life easier for us. Even till date, we are still discovering more applications of nanoparticles. A good example, the first one we'll be considering is the fuel cells. Okay, fuel cells, are very important. They are very good energy source, a very good electrochemical cells that is used to generate oxygen, It kind of help with the reaction between hydrogen and oxygen to release electrical energy. So with fuel cells, you can actually power um, um, a machine with just hydrogen and oxygen. Okay, so that way you don't need petrol, you don't need batteries, you just need water, okay, as the source, okay, for this fuel. So nanoparticle materials are being used in two different ways to lower the cost of fuel cells. Okay, so gone in the days where fuel cells are very expensive, but now with the advent of nanoparticles, the cost has been, brought down. Okay, so platinum nanoparticles are now the ones used, as a catalyst. Okay, so imagine when you're using platinum nano particles, those small size particles, that will help in reducing the mass of platinum you're going to need to produce the fuel cell. So what it means is you need less platinum to produce more cells, okay, which is very, very economical. Okay, secondly, nanoparticles have become an alternative materials, okay, to replace platinum. Platinum is one of those rare metals. They're very, very expensive to to buy. Okay, so number two is delivery of drugs. Yes, nanoparticles have helped with the delivery of drug to specific cells in the body. Okay, so they're very small, so they can be targeted at specific cells in the body. Okay, what this means is, we have billions of cells in the body, and you want to just target maybe 100 cells in a particular spot of the body. All you need to do is get nanoparticle, okay, to administer that. So if there were no nanoparticles, it means you need so much drugs, okay, to satisfy this request or need. But with nanoparticles, you can just release a drug at the targeted spot. That way, you will reduce the volume of drug intake and also reduce the side effects of those drugs, because every medicine has side effects. So if you're taking a large dose so that it's going to be effective, of course, you should also be aware that there'll be consequence of side effects of that particular medicine. But with nanotechnology, you don't have that problem. Okay, it's targeted and to the spot where it's needed, and the side effect is drastically reduced. Okay, so in sunscreen also, titanium oxide, okay, or zinc oxide, these nanoparticles from these two um, substances are used to absorb the harmful UV radiations from the sun. Okay, so nanoparticles will give a better coverage, okay, because of their tiny sizes. So they spread more, they cover more area than the regular titanium oxide or zinc oxide. So they give better skin coverage. Just take, for example, trying to cover a particular area um, with gravel stones and with powder. Which of this material will cover much area? Of course, the powder will cover, they have more coverage than the granite or the gravel stones. Okay, so you have to take note of that the tiny size of the nanoparticles of this titanium oxide and zinc oxide make it possible for ease of spread and cover a large portion of the skin, preventing the skin from exposure to harmful UV radiation. Okay, we have synthetic skin, okay, that is used to treat patients, okay, whether with first or second degree burn, when people um, experience things like this. They lost their skin. So nanoparticles, okay, like those from carbon, have helped to produce synthetic skin that can act as a covering to those burnt area because it's been tested that these nanotubes they are stronger and they are flexible, just like your skin is flexible. Okay, so they are very good, okay, replacement for the skin for patients that have skin burn. Okay, so you can see that nanotechnology have helped a lot in terms of medicine, in terms of technology, in terms of cosmetics, your face cream, moisturizers, and the likes. It has really helped. In fact, in terms of clothing too, some clothes contain this what they call silver nanoparticles, okay, which uh, help, okay, especially in sportswear, socks, things that can stretch. We use um, that, and then deodorant, okay. Silver nanoparticles can also be used for deodorant. Reason being that they help to kill germs. Silver kill germs. So they help to kill germs and help to prevent buildup of bacteria that would lead to body odor, especially in some parts of the body like the armpit and some other parts of the body that are susceptible to um, bacterial growth, okay, and odor. So these are many more the uses of nanotechnology. Okay, even your electronics, we now have chips that are very small, very, very small in size that can still perform the function of the regular size chips. Okay, we have cameras that you will hardly be able to spot, okay, that have been developed, okay, with the help of nanotechnology. All right. With the help of nanotechnology, we have built drones that are as small as insects. Okay. So nanotechnology have helped to reduce the size of even complex electronics. Okay, making them so small and still effective and can still perform the function of the regular size electronics. Okay. However, nanotechnology also have its bad sides. Okay. Uh, you know, to everything that has a good side, we also have a bad side. Okay. So they have some harmful effects, human and the environment. Example is gold. You know, the bulk gold is safe, but gold nanoparticles are not. Okay. Um, One way in which nanoparticles could be harmful is that some way they are so small, so they can penetrate the cell membrane and enter the cell. Okay, unlike the bulk material. Nobody will want heavy metal penetrating their skin. That is not advisable. Okay. Um, so that is one of the major ways that nanoparticle is not safe. Okay. And that is some of the safety concern and we have as scientists. So work is still ongoing to ensure that nanoparticles are safe for use. Um, um, our sincere hope is that one day we'll come up with something that will be free from every safety concern. But however, it has made life easier for us as humans. So before the end of this class, I would like us to go through what we've done again. Um, Number one, nanotechnology or nanoparticles are particles within the range of 100 nanometers to 1 nanometer. They're very minute. They are small size and higher surface area versus volume ratio makes it possible for them to spread better, makes it possible for them to act as a better catalyst, make it possible for them to have wild applications, okay, that we have enumerated in the class today. Okay, we'll stop here today to learn more about fascinating topics about matter, okay, and chemistry as a whole. Make sure you hit the subscribe button, okay, and like this video. And if possibly, share it with one of your friends. At this juncture, I would like to say bye, to meet again.